Hello and welcome to the screencast in TDD27 for my my personal screencast. So this is the project called Frame, which is a web game running on Next.js and using Supabase as a backend. We also have TypeScript, and we're using for UI we're using ShadCN component libraries, which we can quickly see actually here, which are just we modified already made templates. Very nice to use. Anyway, continue. We'll go through the most important parts of the system, and that is mostly game view, game context, and game service. We'll also be touching on other subjects such as the caption voting or the actions such as logging in with a Google account. But we'll start in game view. So game view is essentially when we play the game, this is the TypeScript file that is running. Essentially, this is the biggest file we have. It's a bit smaller than game context, but they're connected. So we have essentially the main game. We can go down here to return, and then we'll return the header and the leave and the join. We'll also have here is the main game. So it says, "Are you the imposter?" You might be seeing a different others. Be careful, different image than others because you don't know if you are the imposter. There's a we want to warn you here, but anyway, so we have a button that just loads everything, blah, blah, blah. And then we come down to the image loading. Essentially, we have on our server side in our URL or our API, we have something that checks if you are imposter or not, which is randomized in the beginning of the round. So we can go quickly to see here, and we can check. So it essentially fetches all the images and checks. Okay, if you are imposter, yes, okay, then you'll get a fake image. So now I'm blind. So you have the real image URL and the fake image URL, and the fake image URL will be set if you are an imposter, and the real one will be if you're not an imposter. And then we have the image category, so we want to see if the imposter doesn't know that they are the imposter, and therefore we must be able to hint that they are the imposter, or they should write something more general to not get caught, or they might be the imposter, but the others don't know, and you don't know if you're the one, so you have to be a bit careful with your captions. So we have some specialized things. Anyway, we have the in progress. Sorry, we have the round face captioning. So this is where the image has popped up, has loaded, and you get 20 seconds to submit a caption. You can write something up to 300 characters, which is the limit. In the end, you can submit it with the set caption submit. And we can go and look on handle caption submit, which is then calls submit multiple votes, or not multiple votes, caption, submit caption, and it's just a post request that sends in all the information it needs to, checks that you are you, and sends it in. Of course, nothing too difficult. Then if we go back correctly, we then have, after the timer runs out, we have the next phase, which is this is just showing the deadline, and there's a button that's commented out, but this is, then we have the voting. So this is when you have given the process, so you have a voting system. So you get shown all the different images, captions, and you get shown the real image, and then you're supposed to vote on your favorite caption. Of course, in this stage, you might find out who's the imposter if they write something too crazy, but we're not going to cover anything more than that. So here we have the function caption voting, and we can go and look at that quickly. This more of these components are not super unsimilar, but they're quite similar. Meaning, I won't go through all of them because it's just a waste of time, honestly. Maybe someone does something cool, but or someone they do cool all of these do cool stuff. But, yeah. So we have a handle submit vote here, which is just call the other function on votes as voted. Yeah, get the point. And this is just some HTML for that. And then we have the deadline again, the debug information, which we don't always show. Some more debug information for the other one as well. We can scroll down to the end here. We have our chat panel on the right side, where we can chat to each other, which is using real-time systems on the Superbase side, which is pretty cool. So we can go and take a look at the game context to look at what's actually making these things work. So a bunch of states. We wanted to use Sustrand in the beginning, but because we already made so much without it, we never ended up actually adopting it. So we have a use effect. So we have a lot of these use effect use game that fetches. If a component is updated, it immediately fetches it, so it's always updated and it's live and it's reactive, which is very nice. So I have the get session, authorization, as well as setup as always. So this is just to get the current user, but currently I want to look at we'll handle. I should look at. There's a lot of different things here, so we can just take a look at the generation code. So when we make a room, we want to generate a code that gets set, and we can share it, and it's unique to that room. We do it here by having the alphabet and numbers, and we can just pick 6 randomly. There's a lot of error handling in these systems. It is mostly error handling, to be fair. But for example, we have the join room, which is a promise. So we say, okay, we do all the checks that that you are a real person. You actually want to join, and you don't spam join. And if you're trying to spam the room by rejoining, we also have blocked that, and also have and then we remove the debounce. So you have a 2-second timeout essentially. So check if the room exists, check if we're already in the room, and then we can actually join room with this game service join room function here, which then just fetches, or in this case post, but and then you just return the data as this type. You can see we have a bunch of different types: start game type, leave room result, which we won't go over super in depth because it's not super important, but they make it a lot easier just sending data back and forth. Hello again. I wanted to talk more about the big files that we use here. We have the game service, which is this one. This is the primary interface to our Superbase backend for all the like game related data. It contains the game service class with static methods to perform operations like creating rooms, joining rooms, starting games, fetching player data, getting current round details, just as get current round, for example. Submitting captions, submitting votes to on those captions, and fetching game results, such as essentially anytime your application needs to write game data to the database, it's likely going through this service. The game context, which is here, uses a React context to manage and provide global game state to various components in our application. The game provider components, let's see, provider, there we go, I'm blind. Wraps parts of the application making game state like the current room, players, current round, user ID, and game actions like create room, join room, start game, leave room, advance to round, which starts next round. Accessible to any child component via the use game hook, so when it updates, they update. It also handles setting up real-time Superbase subscriptions to listen to for changes in the game rooms and player lists, such as updating context state accordingly. It also manages loading states, error handling, and user authentication state changes. Then we have the game view, which is a React component responsible for rendering the main user interface when the game is in progress, as I'll mention later as well. It takes the current room, players, and an on-leave function as props. It uses the use game hook to access game states and actions from your game context. It manages different phrases of a round, captioning, voting results, and final results using the round phase, which I'll show later as well. It handles displaying the large image, managed URL, caption submission forms, voting interfaces, and displaying results via the result view, which we can find here, which we'll also go through later. Component. It sets up real-time subscription for round updates, such as the round subscription, and host actions, such as the broadcast subscription, which is used for the chat to broadcast everything and not store it in the actual database itself. When the host is like skipping, which is a debug feature at the moment, but maybe we'll end up adding it at the end. We're not sure. Also includes logic for fetching necessary data for the current round, such as image details, like image titles. It also provides like UI elements for game controls, like leaving the game and host advancing to the next round or returning to the lobby. It also includes the chat panel, as mentioned. To summarize these main files, which is actually the game service itself, the game service talks to the database. The game context holds and shares the game's current information and actions across the app. Game view shows the game to players and lets them interact with it using information from game context and telling game service, often via game context, what to do. Thank you. Okay, welcome to the third and last part of this. So I just wanted to quickly show the backend, which is this Superbase backend as a service. And here we can see our tables, which will have the game players, which contains the players in the games, the game rooms, meaning we can see like what game code they have, who is the host, what status they're in, when they were created and such, and the round they're on as well. This is displayed in the lobby, where we can see all the games. We have the game rounds, which is where we store all of the rounds, which is the real and fake image, and when the deadline is at, to handle the timer correctly. We've also got a big list of images, because we don't want to fetch all images. We have a list of of the file path to the images and then pick randomly, or not super randomly, but we could pick a category and pick one of these categories to images. And then of course we have the player captions, which is what you write. We can see what you write and we store them and see what round and what game this was, or not what game, but round. And then we have the player votes, which is empty because it every time you go to the next round, it gets deleted, and as well got profiles as well, which it contains the Google profiles of who has connected. We can go and look at the. I wanted to look at the policies, for example. So because we have row line security, RLS, we must have policies for everything. Essentially, if we want to access something, we need to make it a policy. So if I remember correctly, because for example in votes you need to be able to delete your own vote, therefore we made a caption, or we made a policy here which makes you can only delete your own captions, which is called when the next round is starting, so your vote is removed from that game and you can start over. As well as we had the ability for edge functions, which we no longer use, except this one apparently, but we don't use anything more than, or we use the traditional APIs, which, for example, we have the round image URL, which goes through and picks a fake or real depending on if you are the imposter in the round or not. Or we have the start game that starts the game, or when you submit the caption, it inserts the caption. So we have the more traditional APIs to talk to the server directly instead of using these edge functions, because, well, we thought they were we didn't want to have a bunch of code that was like spread all over the place, and keep it try to keep it in one place just to be able to not lose your mind. I think that's all. Thank you for watching.